Welcome to the DIY Honda Garage channel. Welcome to the troubleshooting guide for DTC P0121, which stands for Throttle Position TP Sensor A out of range. This issue is particularly relevant to Honda Civic models from 2016 to 2021. The TP sensor plays a crucial role in determining the throttle position, which helps regulate air intake and fuel mixture for optimal engine performance. When the DTC P0121 code is activated, it indicates that the readings from the throttle position sensor are outside the normal range, potentially leading to poor engine performance or increased emissions. In this presentation, we will delve into various aspects of this error code, including its components, possible causes, symptoms, and a step-by-step troubleshooting process to effectively diagnose and resolve the issue. The DTC P0121 pertains to the throttle position TP sensor A, which is a vital component situated on the throttle body assembly. This sensor monitors the position of the throttle plate, sending critical data to the Engine Control Module, ECM, to manage engine performance and throttle response. The throttle body itself is typically located between the air intake manifold and the engine, making it accessible yet complex, as it also provides pathways for other critical functions, such as air intake. If this sensor goes out of range, it compromises the engine's air-fuel mixture and can result in a myriad of performance issues. It's also important to note that poor electrical connections or damaged wiring at both the throttle body and the ECM can exacerbate the problem. Properly addressing these components is essential for resolving this diagnostic trouble code. Several potential causes can lead to the activation of DTC P0121. First and foremost, a faulty throttle position sensor, TPS, can fail to provide accurate readings, signaling to the ECM that the throttle position is out of range. Secondly, damaged wiring, particularly in the voltage circuit connection, VCC3, or throttle signal circuit, THL1, can interrupt data transmission, further complicating sensor readings. Additionally, loose or corroded electrical connections can lead to intermittent issues where the system appears to be functioning normally at times, yet fails under specific conditions. Ensuring these components are functioning properly is crucial to finding a lasting solution to this error. Lastly, it's important to verify that the engine control module is not at fault, as a malfunction in this unit can also result in similar symptoms. When facing DTC P0121, several symptoms may become evident while operating the Honda Civic. The most prominent symptom is poor throttle response, where the vehicle may struggle to accelerate or respond adequately to gas pedal input. This could make the driving experience frustrating and potentially dangerous. Additionally, the engine may stall unexpectedly, particularly during idle or low-speed operation, further hampering vehicle safety. The check engine light will also be illuminated, prompting the driver to have the vehicle inspected. Finally, in some scenarios, the vehicle might exhibit various ranges of power loss, affecting overall engine performance. Recognizing these symptoms can help you diagnose the issue more effectively. The first troubleshooting step involves verifying the problem by setting the vehicle to the on mode. This activates the electronic components without starting the engine. Subsequently, you will clear the diagnostic trouble code, DTC, using the Honda Diagnostic System, HDS. This process resets the vehicle's fault memory, which is crucial for assessing whether the problem is persistent or has resolved itself. After clearing the DTC, wait for at least 10 seconds to allow the system to reset completely. Following this, check for any pending or confirmed DTCs using the HDS. If DTC P0121 appears, it confirms a continuation of the issue and you can proceed to the next troubleshooting step. If it does not appear, there may be an intermittent issue, necessitating inspection of electrical connections at the throttle body and the engine control module. For the second troubleshooting step, turn the vehicle to the off-lock mode. This allows you to safely disconnect the throttle body 6P connector, which is the electrical connection to the throttle body. Then, switch the vehicle back to the on mode. Next, you will measure the voltage between test points specified in the diagnostic instructions. Here, test point 1 refers to female terminal number 3 on the throttle body 6P connector, while test point 2 refers to female terminal number 5 on the same connector. Ensure that you observe the voltage reading correctly. You are looking for approximately 5.0 volts. If you detect this voltage, it suggests the initial wiring and electronics are functioning correctly, directing you to step 6 for further tests. If you don't find this voltage, additional investigation into wiring integrity and potential issues is warranted. Moving on to the third troubleshooting step, begin by switching the vehicle back to the off-lock mode. This precaution is necessary for safety before making any electronic connections. Following this, you will jump the SRS supplemental restraint system line with the HDS and wait for more than 1 minute. This step is vital for ensuring that no airbag faults interfere with your diagnostic. Once that is completed, disconnect the PCM connector E, which incorporates 80 pins and links the powertrain control module to the vehicle's systems. Now, you will check for continuity between the specified test points. Test point 1 is terminal number 5 on the throttle body 6P connector, and test point 2 is body ground. If continuity is present, it confirms a short within the VCC3 wire. In such a case, repairs need to be executed on the wiring from the PCM E75 to the throttle body. If no continuity exists, further diagnostics will be necessary. In this fourth step of troubleshooting, you will again check for continuity between test points, focusing on the VCC3 wire. Ensure that the vehicle remains in the off-lock mode for safety before testing. You will require terminal number 5 from the throttle body 6P connector for test point 1 and terminal number 75 from the PCM connector E for test point 2. Utilizing a multimeter, check for continuity between these 2 points. If continuity is present, it confirms that the VCC3 wire is functional, allowing you to move on to the next step. However, if there is no continuity, it indicates that the VCC3 wire is likely open, suggesting a break in the wire that needs repairing between the throttle body and the PCM. Addressing this issue promptly is critical for the accurate reporting and functioning of the throttle position sensor. Step 5 focuses on checking continuity in the SG3 line. Similar to the previous steps, ensure the vehicle is in the off-lock mode. This step requires you to measure continuity between the throttle body 6P connector's test point number 3 and terminal number 76 of the PCM connector E. This particular wire is critical for the throttle sensor's operation. Utilizing a continuity tester or multimeter, if continuity is confirmed, it indicates that the SG3 wire is intact and functional, allowing you to proceed to the next stage of testing. However, if you find no continuity, it signals an open circuit in the SG3 wiring between the throttle body and PCM, which requires immediate attention and necessary repairs. Ensuring that this wire is in good condition is crucial for proper communication between the throttle position sensor and the PCM. For this sixth troubleshooting step, you will check the THL1 line for any short circuits. As with previous steps, start by setting the vehicle to the off-lock mode. Disconnect PCM connector E and measure continuity between terminal number 6 on the throttle body 6P connector and body ground. If continuity is established, It suggests that there is a short in the THL1 wire between the PCM E50 and the throttle body. This requires repairs to resolve the short circuit. Conversely, if no continuity is detected, it points to the absence of a short in the THL1 wire, prompting further investigation into Step 7 to locate any potential open circuits. The seventh step involves checking continuity for the THL1 line again. Ensure that the vehicle remains in the off-lock mode for safety. For continuity testing, you will measure between test point 1, which is terminal number 6 on the throttle body 6P connector, and test point 2, which is terminal number 50 on the PCM connector E. Using a multimeter for this test, if continuity is confirmed, it indicates that the THL1 wire is functioning correctly, and you can move on to the 8th and final step of this troubleshooting guide. If no continuity is detected, however, it signifies an open circuit in the THL1 wire between the throttle body and PCM, necessitating immediate repair of the broken wire to restore full functionality. The final troubleshooting step involves checking the throttle body itself for faults. To begin, substitute in a known good throttle body to eliminate the possibility of it being defective. After replacing the throttle body, reconnect all electrical connectors securely to ensure proper communication between components. You will then exit the SCS mode with the HDS. Following these actions, turn the vehicle to the on mode again and clear any existing DTCs using the HDS. Wait a minimum of 10 seconds before proceeding to check for any pending or confirmed DTCs following this reset. If DTC P0121 persists, it indicates that the replacement throttle body is functioning correctly and further investigation is required, possibly involving the engine control module, which may need to be substituted. If the DTC no longer appears after replacing the throttle body, it signifies a successful resolution to the initial issue. Final verification of repairs is crucial in ensuring that the issue related to DTC P0121 has been successfully resolved. Start by confirming that all necessary repairs and replacements are completed according to the diagnostic findings. Once repairs are made, check once more for any remaining diagnostic trouble codes, DTCs, using the HDS. The system should ideally indicate that no DTCs are present, which will confirm that the repairs were effective. Finally, a thorough test drive should be performed to assess overall vehicle performance and confirm that there are no lingering issues, such as throttle response problems or check engine light reactivating. A successful test drive with no issues signifies that the vehicle is operating as intended. Preventive maintenance is a critical aspect of vehicle ownership that can help avoid future occurrences of issues like DTC P0121. Regular inspections of the throttle position sensor and associated wiring can help identify early signs of wear or damage. Ensuring that all electrical connections are clean, tight, and free from corrosion will significantly reduce the likelihood of performance issues. Additionally, performing a throttle body cleaning can help maintain optimal airflow and performance. A clean throttle body allows for better fuel-air mixture regulation, thereby supporting engine efficiency. These maintenance practices not only promote the longevity of your vehicle's systems, but also help ensure a smooth and reliable driving experience. In conclusion, understanding the role and functions of the throttle position sensor, TPS, is paramount when diagnosing DTC P0121. Performing a thorough, step-by-step troubleshooting process is essential to identify the underlying causes accurately, whether they relate to wiring, the sensor itself, or the engine control module. By adhering to the outlined troubleshooting steps and properly verifying repairs, you can quickly address issues related to this code. Furthermore, implementing preventive maintenance strategies is vital for ensuring the continued functionality of engine components. Taking these proactive measures not only enhances vehicle performance, but also extends the life of critical systems, ensuring a secure and efficient driving experience. Please like and subscribe to the channel. See you next time!